Lesson 10.6, Segment Relationships in Circles. Let's say a person is stuck in a water pipe with an unknown radius. Who knows how he got in there? Anyway, he estimates that surface of the water makes a 4-foot chord near the top of the pipe, and that the water is 6 feet deep. So this is the surface of the water here. How much room is available for his head? So we want to know this up there. Well, to answer this question, we're going to have to know some theorems. Our first theorem is the segments of chords theorem. If two chords intersect in a circle, then the products of the measures of the segments of the chords are equal. All right, let's go back to our water pipe. If all the way across was 4, this was 6, and we're looking for x. All right, if this is going, the 6-foot depth is going right through the middle, the 4 we could split up into 2 and 2. And so this says we're just going to product our pieces of the chords. So it'll be x times 6 equals 2 times 2. So 6x is 4. Divide by 6. 4 over 6 and reduced to 2/3. So there's 2/3 of a foot available for the guy's head. It's really not a whole lot of space. You should stay out of flooded water pipes. Our next theorem is the segments of secants theorem. If two secants are drawn to a circle from an exterior point, like in the picture, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant segment and its external secant segment. Wow! Yeah, let's fix it. So this is saying when we come from a point on the outside and we're going to the opposite side of the circle, it is the whole thing times the part outside. And that'll equal the whole thing times the part outside the circle. So to find x in this diagram, for the top one, the whole thing is 12. The part outside is 3. For the bottom one, the whole thing is x plus 4. The part outside is 4. So it's the whole thing and the part outside, the whole thing and the part outside. We can distribute, that would be 4x and 16. Subtract the 16 and divide by 4, so you'll get 5 equals the x. So it's the whole length from where it intersects to the other side of the circle times the part outside the circle. The last theorem for today, segments of secants and tangents theorem. If a tangent segment and a secant segment are drawn to a circle from the exterior point, then the square of the tangent segment is equal to the product of the measures of the secant segment and its external secant segment. Like the previous one, this can still be summarized as it is the whole thing times the part outside would equal the whole thing times the part outside. In the case of the tangent, the whole thing is outside. For the secant, remember the secant goes from the intersection to the opposite side of the circle. So I'm going to find x. For the top one, the whole thing is x, and the part outside is also x. Hence, it's x squared. And like in the theorem, it's the square of the measure of the tangent. For the secant, it's the whole thing. So add those together, times the part outside. So x squared equals 324. And then you'll square root. So x is 18. It's the whole thing times the part outside. When it meets outside, it's the whole thing times the part outside.